Hi everyone, welcome to MATLAB and Simling Racing Launch. I'm Veer from the Student Programs team and really excited that we have a guest speaker, Nicolò from Dynamis PRC Racing team. And then Nicolò is going to talk about his Formula Student vehicle model that he developed using Simscape Multibody. So over to you, Nicolò. Why don't you introduce yourself, your team, and what you're going to talk about?
Okay, thanks, Veer. Hi everyone, I'm Nicolò Poncia from Dynamis PRC. Currently, I'm the head of vehicle dynamics of Dynamis PRC. We are a team of Formula students. Currently, we are competing both in the electric and driverless category. We race since 2004, so it's quite a long time. And the team is composed by roughly 130 members. So we are quite a lot, but in the last 3 years, the team was revolutionized um, because we switched both to the electric and the driverless category. The electric in 2020 and the driverless category in 2022 with quite a lot of success. In fact, in the last year season, we scored a podium both in Formula Student Germany and Formula Student East.
Perfect. So it seems like a huge team, Nicolò. I mean, and I can see the success you all have achieved. So let's move ahead and can you give an overview what you're going to show today?
Yeah. Today we are going to show the multi-body model. We developed a full car multi-body model in which all the moving components of the car are actually modeled. Like we can see in this short demonstration, this was recorded the onboard during track testing in Arese, and we compared the video giving the same inputs to the actual model, and the results are quite stunning.
Perfect, perfect. So yeah, I mean, we can see that you have extensively used SimScape Multibody. So those who are new, just to give an intro, so SimScape Multibody is a part of SimScape, and with SimScape Multibody, you can enable multibody simulation of 3D mechanical system, wherein you use different bodies and joints to assemble and including import from CAD. And at the same time, as you can see on the slide, you don't need to derive the equations. So with this short introduction regarding SimScape Multibody, uh, let's move to the agenda and see that what we are going to cover today. So today, Nicolo will share the motivation behind this multi-body simulation, and then he'll also talk about model capabilities, and then the part which I'm really excited is the software demonstration, and then finally we'll move to the results and model verification, followed by key takeaways, future plans, and resources that will be necessary or required if you're interested to build some models like these. So perfect. So let's go ahead, Nicolo, and tell us the audience like what motivated you to build such amazing model.
Yeah. Uh, we developed previously from the multi-body model already a single track and a double track model, but to further enhance the model fidelity and the model complexity, we switched to a full car multi-body model. The advantages of the multi-body model are actually an high level of fidelity. In fact, every component is physically modeled and actually represents what happens to the car. And also, an high versatility level is present. In fact, we can switch between different suspension configuration in a matter of seconds. Another great advantage is the easiness of understanding. In fact, you don't have to derive equations, but you only need to actually comprehend what the car is actually doing. Also, an high level of user-friendly experience is present. In fact, by using all the MathWorks environment, all the process are quite graphical and ready to use. In addition, also the model is fast to run,
Okay.
despite what somebody can think. The model is quite complex, but nevertheless, it's also very fast to run.
Okay, perfect. So I mean, just to add, or if I summarize that, the motivation, one more motivation which you can talk about, or maybe you already covered in these topics, is that you can model the dynamic behavior of a vehicle, and then the best thing that you can do, and even your team members, those who are going to follow this model, is you can have different vehicle configurations before you take any critical decision for your vehicle. So perfect. So this seems exciting, and let's move ahead and can you walk us through the capabilities of your model?
Yeah, the model is actually able to perform a wide range of simulations. In fact, not only basic maneuvers are possible, but a lot of capabilities are implemented. Starting from the simple open loop driver, we can perform ISO maneuvers like ramp steers or sign steers in order to have an objective evaluation of the car performances. In addition, we have a closed loop drivers that allows us to perform lap time simulation by following a given trajectory. Also, we have a 7-post rig where we can excite all the four wheels, plus also the emulate the aerodynamic forces. Other than that, we have also flexible bodies that allows us to understand how compliances actually modify the car behavior. And thanks to that, also it is possible to implement kinematics test rigs, where we can see the dynamic angles of the suspension and how every component is actually working. Uh, Last but not least, also we have the control systems implementation. In fact, we have all the electronics behavior and also all the control systems implemented. And also early in the design phase, we can implement control systems and see how they actually perform.
Okay, so I can see multiple model capabilities you have, and I suppose that any student or any team who's looking for these kind of simulation, your model covers all of these important topics. So with this, let's get started and let's move to the software demonstration, which I'm really excited to see.
Okay, perfect. So this is the actual multi-body environment. The environment is implemented thanks to the MATLAB project capabilities. In the MATLAB project, we have a lot of folders, but the most important one is the library folder. In fact, the multibody is not only a simple Simulink model, but is a Simulink library. In this way, we can implement a singular component such as a steering system or other tools, and then and only then propagate them in a specific Simulink. The library is organized in a way to have a subsystem for each macro assembly present in the car. So we have, for example, kinematics, elastics, tires, or steering system. In this way, we can model each macro assembly like as we have in the car and in the CAD, and then only then assemble them in a full model. So we can go through, like for example, the steering system. Each subsystem is organized in this way. We have a block steering system that will be the one directly placed in a Simulink model. and then we have another subsystems called components. So in the first one, the steering system is actually a variant subsystem. In fact, different types of steering systems are modeled. For example, complete systems, only rack or a fixed steering system. All these different variants are actually implemented in the component subsystem. In this one, we have each component specifically modeled.
Yeah, thanks, Nicolo, for going through your library that you have created. And I can see the amazing part is that each of these components you're having variant subsystems, so that depending upon the complexity, you have added multiple subsystems. Now, going ahead, can you also show like what does that simple system or the complex system mean in these scenarios? Like, let's take an example of the kinematic one.
Okay, so we can go through all the variants that we have implemented for the kinematics. There are quite a lot, but for a specific reason. In fact, we have like the simplest version that doesn't take into account what are the constraint reactions. And like in this case, the wishbones are attached to what is the chassis thanks to only a revolute joint. We don't have to calculate an hyperstatic assembly, but we actually lose the ability to estimate what are the forces at the chassis. This approximation is not done in the rigid kinematics. In fact, in this assembly, we have not a revolute joint, but we have two spherical joints for each kinematic attachment. In fact, here we have an hyperstatic assembly. It's slower to compute, but it gives us a lot more of informations.
Okay, okay. Perfect, perfect. And do you also have a flexible body kinematic system, or is it in a different one?
Yeah. In addition, we also have the flexible one. In this case, the main structure is actually the same. What it changed is this component that is not anymore a simple wishbone, but is modeled using the flexible bodies capability built in Simscape. In this way, we can assign to the body what is a damping matrix, a stiffness matrix, and a mass matrix. In this way, we can simulate what are the compliances performing in the car.
Okay, perfect. So for the flexible body, you have defined a mass and stiffness matrices. Okay, perfect, perfect. That makes sense. Okay, yeah.
So once all the singular components are implemented, we can finally assemble them in what will be the final car. In we have currently we have two different models. The most used is the multi-body baseline model. This one is organized so that the left subassembly is the actual multi-body model, while the right subassembly performs all the post-process calculation in order to further enhance what are the logged signals. So going through the actual multi-body car. So going through the actual multi-body model, we can see that every subassembly is connected with others, like it happens on the actual car. So we start from the word subassembly, where we define all the car properties and all the main structure. Then we have all the subassembly interconnected, starting from the chassis. To the chassis are connecting both the steering system and the kinematics. To the kinematics are then attached what are the powertrain. which is composed by both the motor and the brakes. And finally, we have what are the tires that communicate directly with the ground that is defined in Simscape Multibody.
Okay, okay. So, Nicolo, can you get into the tire subsystem? I just have one question, that what tire model you're using, and again here I can see variant subsystem, please.
Yeah, so for the other subassembly, also for the tire, we have variant types. We have the Passeca, which is built in Simscape, and also we have MF tire from Siemens. Lastly, we have what is a setup wheel that we use to perform kinematics analysis.
Perfect. So can we go inside in one of the subsystems?
Yeah.
Let's take the first one. Yeah. Okay, so here you're using the magic formula block from the Simscape multibody. Perfect. So can you double click on this, Nicolo? I have one interesting and very common question which is being asked by many students. So in this, we require the .tir format for modeling the tire. Did you do some kind of calculation or algorithm did you wrote to convert the raw tire data into a .tir format, or there was a different approach from your team's end?
Yeah, we use .tir format and we get it directly from Pirelli. In fact, we have a direct collaboration with them and
Okay.
we perform tests that where we can actually
Oh,
implement a .tir format.
okay, perfect. Great. Thanks, Nicolo. I also have one question. I can see there are multiple parts that has been used in this, and these are also shown in your mask. So have you used the file solid block to import these parts individually, or you have directly imported the full CAD assembly?
Yeah, initially we decided to import the CAD using the sim mechanics exporter, but it is a very fast approach to start from zero. But then we decided to start from scratch.
Okay. So and also I'm curious to know that does your model also contain aerodynamic in this? And if it has, can you walk us through that?
Okay, so also for the aerodynamic package, we have different variant configuration. The most complex one measures what are the radius of the chassis relative to the ground. The radius are used in order to interpolate the aerodynamic forces maps that the aerodynamics department give us. Then we can also implement what is the DRS activation. And once the DRS logic is considered, we can directly apply an external force to the chassis so that we can emulate what are the aerodynamic forces.
Perfect, Nicolo. I think we now have a good idea of how your system works. So, and I remember you have also developed a MATLAB app for a user-friendly experience. So why don't we go through that, and then after that we can run the simulation and go through the results. So yeah.
Yeah, we also developed an app which is called the Driver GUI. In this app, we can rapidly implement driving maneuvers, both open loop and closed loop. Open loop maneuvers, in the open loop tab, we can define time series of accelerator and brake pedals and also steering angles, while in the velocity reference, we can impose velocity reference and also a steering angle, and then the velocity reference will be followed by a longitudinal driver.
Okay. And so how have you developed the driver in this case?
The longitudinal driver is the one that is already built in the vehicle dynamics block set. So it's
Okay.
the longitudinal driver, while we have also a driver capable of following a trajectory. In this case, it's fully built by us internally.
Okay, perfect, perfect. Yeah, let's go ahead. Yeah.
For example, we can load a simple maneuver. So the selection panel open up and we can select, for example, a sine maneuver. When we load the maneuver, the inputs will be displayed in the graph below and all the settings will be loaded. Then by selecting the set as current button, we can actually propagate the data directly to the multi-body model that we will perform.
So in that case, this app is helpful in the sense that you don't have to go to each of the subsystems and manually input the values, right? This app will do the job, right?
Yeah, exactly. Instead
Okay.
of directly writing it manually in a script.
Yeah. Perfect. Perfect. Yeah. So if we are all set, why don't we run one simulation to just see like what output we are getting?
Then once we set up the maneuver from the app, we can actually run the simulation. A great advantage of the multi-body package is that you can actually and graphically see what the car is actually doing. So also the debug time is also further reduced.
Yeah, and similarly, I think you can perform different track simulations or closed loop simulations as well. So yeah, so perfect. This looks great, Nicolo. And along with that, this is one thing is that we are having the simulation where you are visualizing this, but at the same time, the data that you need that can also be logged to different sensors which are there in the multi-body. Or if you're using different joints, the joints are having sensors to sense the forces, acceleration, velocity, and other parameters. Perfect. So Nicolo, can we do one more thing? Can we have one closed loop simulation as well, just to have a look into some kind of track simulation?
Yeah, for sure. Apart from open loop maneuvers, we can also perform closed loop maneuvers. In this way, we can perform lap time simulations of the various tracks that Formula Student is composed by. In this case, we are going to perform a simulation of Formula Student Germany Autocross.
Perfect. So this is quite helpful. So with this, with covering, we have covered the closed loop simulation, we have covered the open loop simulation, and you also walked us through the whole subsystem, how you have built it. So I remember, Nicolo, that you were also talking about the GGV plot that you have obtained. So would you mind going through that?
Yeah, for sure. Yeah, for sure. We have the GGV diagram. In addition, the GGV diagram is actually created thanks to an automatic script, so that we don't have to run a lot of simulation, but it's everything automatically done. This is done by this GGV script, which runs thanks to the parallel toolbox a lot of simulations. Once they are completed, we get this Excel in which all the accelerations are written, and also we can graphically um, and then we can also graphically see what the GGV diagram actually is, like in this case.
Okay, yeah, I can see that the aerodynamics force over the download force is basically working so that I mean, the envelope is growing as we're going upwards. Okay,
Exactly. We have with the increment of speed, we can maximize what are the lateral accelerations and the braking acceleration. But then we get to the point where we are power limited, so the longitudinal acceleration are quite reduced.
great, Nicolo. I think this is also an important piece of information for the teams. And yeah, so let's do one thing which I'm also curious about is that you have showed us a lot of simulations. So have you also done any kind of validation to validate with the results that you have obtained through simulation?
Yeah, we also validated the model using ISO maneuvers. In this case, we can see what is a ramp steer maneuver, where the driver gradually increment the steering angle. In this case, it's plotted the lateral acceleration, and we can see that the model fidelly represent the reality.
Okay, yeah, you can see. I mean, the simulation data that you have obtained is almost matching up with the data that you have acquired by logging. So I'm just curious, Nicolo. I mean, the mismatch, a little bit of fluctuation that we see after maybe I would say after 7 seconds. Any thought on this? Like, what do you think? Like, what's the reason that at that place we are getting more fluctuation?
Yeah, all the validation process is actually focused on the input parameters, because modeling the car is actually simple. What is of complex modeling is the parameter that we give to the multibody model. In this case, we have that the multibody model actually have a greater lateral acceleration than the actual car. I think that's it's due to the modeling of the tires, which overestimates the capabilities of the tire.
Okay, okay, yeah, yeah, that could be one of the reasons. So yeah, perfect, Nicolo. So we have discussed the results and how you have validated these results. So let's go ahead with the key takeaways that you want to share with the viewers.
Okay, so after we have seen the model, I think that what we learned was the high versatility and accuracy of Simscape multibody models. If they are approached in the right way, this means using MATLAB projects and Simulink libraries and all the MATLAB capabilities. The implementation process is actually simplified and available to everyone. Also, in the last slide, we also discussed the importance of correct input data in order to perfectly model the car.
Perfect, perfect. I think I would I like the point, the last point that is inputting the correct data, because even though you model and in case the teams or students who are working in such kind of modeling environment, if they're not if they don't have the access of right correct data, they should write that as a note in the model, specifying that there's a limitation that the models the values have been estimated or the way they have taken, so that in future if someone is going to work on that, that person will be aware of what changes that person needs to do. Perfect. Yeah. So, yeah, thanks, Nicolo, for going through your future plans and all the best. And anytime if you need our support, feel free to reach out to us. You know our contact details. And for the viewers who are watching this video, you must be wondering that how do we learn if you want to implement such kind of vehicle simulation? How do we go ahead with that? So I would suggest if you're completely new, go through the documentation page, getting started with Simscape Multibody. So at least you'll get an understanding of how you connect different bodies, rigid transforms, how you define the constraints. And further, once you have done with that, then you can there's a GitHub repository, and it's also available on File Exchange. That's a Vehicle Dynamics 14 DOF model. So that will also give you more understanding. And further, then you have options. If you are a student of Formula Student competitions, we have a Formula Student Simscape multi-body vehicle model. And if you need the access for it, feel free to reach out at racinglaunch@mathworks.com. And then we also have Simscape vehicle templates, which is a library that contains library blocks and configurable vehicle model that you can use for a wide range of vehicle design tasks. So with this, we are at the end of the video, and these are the Racing Launch resources. So multiple times I mentioned the email ID. So this is the email ID, racinglaunch@mathworks.com. You can reach out to us with the queries, and if you're also looking for the Formula Student multi-body model. And then if you're on Facebook, feel free to join our Facebook group. And then there are multiple resources like how we have this video with Nicolo on the Racing Launch channel. So you can also access all the other videos by going through this student tutorials and videos link. And then for software offers, please check out the link provided over here. And then you can also go through our student launch blog where there are multiple technical blogs related to automotive, robotics, and aerospace and other technologies. So, yeah, Nicolo, thanks a lot. Thanks for sharing your work with us and all the best for all your future plans. And I'm sure that viewers are going to love this video and get to learn and they're going to get motivated to how to perform multi-body simulations using Simscape Multibody. Thanks a lot.
Yeah, thanks everyone.